Okay, good morning. The title of our project is Future Operational and Normative Implications Presented by Advanced Air-Breathing Hypersonic Autonomous Strike Aircraft and Exo-atmospheric Spaceplanes, and the challenges posed for nuclear risk mitigation.
So this presentation is structuring this in three sections. First of all, we're going to explain a little bit what we mean by nuclear risk in this context, and then we're going to a little bit delve into details and explain you what are the incentives in actually developing the technology we're going to explain you today, and what are the disincentives, mainly technical and normative stuff. So what do we mean by nuclear risk? Essentially, with this project, we try to assess the risk of autonomous system to actually spark an escalation and ultimately a nuclear war. So we're trying to prevent and present some incentives that might be strategic to develop, but also some disincentives that we should be aware of.
Yes, so we decided to examine the nuclear escalatory risks presented by anticipated advanced autonomous aerospace applications, and we specifically selected two. Firstly, that's hypersonic autonomous aircraft, and then secondly, the autonomous space plane. So our objective was to, speculatively evaluate the projected utilities and risks of these anticipated systems. Of course, it is worth noting they remain highly conceptual, developmental, or merely in the prototyping stages, and of course entirely classified. So on our part, any unfounded supposition or conjecture must be avoided. Indeed, any of our inferences must be very much cautious and qualified. Firstly, the hypersonics. The hypersonic strike reconnaissance aircraft, hypersonic obviously denotes a speed exceeding Mach 5, or 5 times the speed of sound. Such a craft would be air-breathing, as in flying in atmosphere at high altitude, probably utilizing what's called a combined cycle turbofan scramjet, and they'd probably use some type of ceramic radar-absorbing material to minimize their radar cross-section. Now, in defining nuclear risks, we consider escalation pathways, which are most readily identified through the strategic missions notionally ascribed to these platforms. And indeed, for the autonomous hypersonic drone, it is this tail hunting. So as the hypothetical utility as a disarming counterforce instrument, and that is to mean they would hunt an adversary's land-based, road-mobile nuclear ballistic missiles, or transporter erector launchers, so TEL. And these drones have quite desirable characteristics in this regard. So that would be the survivable penetration of non-permissive airspace. They'd be excellent conventional counterforce tools because in contrast to traditional scenarios, they wouldn't use nuclear weapons, probably. And indeed, they would receive tactical cueing from electro-optical, infrared, or synthetic aperture radar satellites, which means it can compress the search area and make their job a lot easier. Perhaps one of the most compelling operational imperatives which motivates the fielding of autonomous weapons more broadly is the assumption that in any future near-peer or peer-on-peer major war, the electromagnetic spectrum would be highly contested, and thus tactical jamming conditions would preclude a reliable data link between an unmanned platform and a human operator. While most jam-resistant communications are constrained by range and bandwidth, tactical autonomy is very desirable for any kind of platform intended for a non-permissive environment. Of course, that implies pre-delegating the authority to kinetically prosecute a target that's been predefined or pre-designated, which can raise quite a lot of implications. The second application we considered then were spaceplanes. These sound more science fiction. They're actually more tractable. These exist today, unlike hypersonic drones. A true spaceplane would be a single-stage orbit spacecraft capable of taking off and landing like a fixed-wing aircraft under its own power without expending external rocket boosters. It would operate then in the exo-atmospheric domain as a true spacecraft and then return to Earth as a glider. Our study was actually initially prompted by the secretive and very elusive X-37B orbital test vehicle, which of course remains entirely classified. So the MSPs have a lot of different missions. Like with the drones, we would identify their risk through the missions they might have. And we tried to find out how and why they might be used. And these are the three missions. In the first instance, as an anti-satellite weapon, or ASAT, perhaps on orbit for months, they might present escalatory risks during pronounced crises. There are persuasive incentives to disable an adversary's orbital infrastructure prior to launching terrestrial operations. But more intriguing, perhaps, are the notional strategic missions, the second two. And these are boost phase ballistic missile defense and orbital bombardment of terrestrial targets as part of a broader counterforce disarming effort. So space-based ballistic missile defense remains notably controversial within defense circles generally. It is simultaneously derided as being hopelessly untenable and also venerated as being a means of transcending strategic vulnerability. And there are a lot of limitations to that. I won't go into them here. But there are a lot of technical limitations, mainly to do with propellant, the attritional vulnerability of the constellation, and they apply to the MSP as well. So at best, while these things could potentially be surged in a crisis to provide localized defense, the coverage wouldn't be meaningful. So perhaps then more alluring and technically feasible is a prospect for the third item here of using MSPs to conduct orbital bombardment of terrestrial targets, presumably with either nuclear or conventional munitions, as deployed as part of a broader disarming effort. Traditionally, conceptual explorations of orbital bombardment entailed imagery of deorbiting long kinetic rods that might attain a re-entry velocity of maybe 3 or even 10 kilometers per second. Undoubtedly, though, MSPs would probably use nuclear weapons for this role, or at least more traditional conventional munitions. But the idea of putting an MSP in orbit during crisis with an explicit counterforce role would undoubtedly be insanely destabilizing. So, thank you.
So we're now going to talk about normative and political disincentives that also, of course, this technology carry with them. So first of all, what about the autonomy itself? We saw that many of these systems are autonomous. So first of all, we have a problem with the autonomy itself because human-AI interface and the automation bias, which is like a psychological factor that can affect the human operator, can interfere with the efficiency of those systems. And second, of course, those systems has been AI-enabled, can be spoofed or simply deceived. Second point is the implication with the international humanitarian law. So as these AI-enabled systems can be, of course, like are based on algorithms, it's legally arguable if they can be legally held responsible for casualties or even injuries to human beings. And so we claim for some law enforcement to actually clarify this point. Second point, we have some geopolitical disincentives that are lie on an international level and on a national level itself. So the international concerns is that those technologies can actually spark an arms race instability, and of course we don't know if the dual use of this systems can also spark some concern in terms of dual use because of the conventional and unconventional and nuclear use of those planes. Second is the national risk calculus that changes between country to country because of the positive and negative control attitude of a country towards nuclear weapons and armaments and the threat to secure a second strike that might actually push some countries to develop those systems because they feel unsure about the capabilities. The third point is, of course, like internal mistrust in some regimes that might push some of the countries to, such as China, for example, which doesn't really rely on their elites and junior officials to actually deploy those technologies to cope with that. Third point is the weaponization of space, which is distinct from the militarization of space, so the military use of space that happens with like satellites, for example. Weaponization of space, of course, means like actually placing weapons on space. In this case, with space planes, for example, as you see in the image, so the X-37B, that could actually take off from the ground and orbit in space and then get back on the land. Technically, it could carry nuclear weapons, but obviously there's a treaty from 1967, the Outer Space Treaty actually bans and prohibits placing nukes on space, but in this case it's unclear if orbitating nuclear weapons would be legally allowed or not, so we claim for some law enforcement in that realm as well. So thank you for your attention, and we look forward for your questions, and yeah, thank Irina, and thanks to our research manager and mentor, Matthew Jensel. Thank you.